I'm standing right now at the entrance to Carpinteria Salt Marsh at just a little bit after the peak high tide. We have some really nice extreme tides because of the new moon right now. So you can see the water level here at the entrance. The water is coming in through here. You can see a little bit of the ocean swell drawing in, the water moving up. So the tide is high coming into this salt marsh and inundating the marsh with seawater, mixing in with the fresh water that's flowing down from the streams that feed this incredible marsh. One of the things that we'll look at is how salinity changes along the whole marsh, going from the ocean inland, and then also look at it over time, looking at high tide versus low tide. So I'm going to take a salinity measurement. We've got this probe here. It's a Hanna probe, and it's just an electronic probe that's going to measure a few parameters. I have it set for pH, dissolved oxygen, salinity, and temperature. The key concern here is really looking at how salinity varies across this marsh, because salinity is such a critical factor for all of the organisms that are living in the water, in the mud, all around. So I'm going to step down. And by the way this probe works to measure salinity is because salts are ions. They have a little electrical charge. So this is literally measuring the electrical charge in the water, the conductivity of it. There's a few different ways we can measure salinity. This one is the most accurate and most commonly used in science and oceanography. So I'm just going to stick the probe into the water and let it calibrate for a moment. So we got a nice reading here. I have a salinity of 32.3 PSU, or parts per thousand. And just for fun, I'll tell you what the temperature is. It's 13.3 degrees Celsius. We've got really good dissolved oxygen, 7.3. That's almost as high as dissolved oxygen will get in the ocean. Up to about 8 is really high. And a good moderate pH of 8.04. So what we're going to do next is walk up the stream and take salinity measurement at a few points until we get to the headwaters that feed right into this reserve. So right here, we've just come around the corner from the entrance of the reserve where the seawater enters into this marsh. And this is the freshwater stream that flows in. So I'll take the salinity here. Again, we're just at about peak high tide, so as much seawater that's going to come into this marsh has already entered. And pretty soon, I think right now we're at slack tide, and soon we'll see a current starting to move out. And let's see if our probe, hang on. Sorry, we might need to start this one over. It just turned itself off while I was talking. Okay. It's 32.3 PSU here. Dissolved oxygen 7.2. Temperature 13.3. pH 7.99. So you can see the salinity is the same as it is just there around the corner at the seawater entrance. All right, let's take a walk up and we'll take a few measurements on this stream as we go towards the entrance. So we're just about halfway between where the ocean is entering the reserve and this creek that is flowing into it. And I can see that the high tide, we're just passing the slack high tide, and it's starting to turn. You can see the water movement is now starting to flow out of the marsh. So let's compare the salinity, the ocean measurements, or the water measurements here. One of the things that I love about slack tide is how clear the water is. The ocean has come up. It's like that pause between breaths when the water comes in, and then before it starts to flow back out again, it gets really still. You can get some really good water clarity. So I can see all of the submerged vegetation. All right, so we have our measurements. Pretty similar to what it was at the mouth, not surprisingly. 32.3 is our salinity. Our pH is holding at 7.99. Dissolved oxygen, 7.41. And our temperature is about the same at 13.24. Now we have two different channels coming, whoa, not fall in, coming through. And the way that they flow in, the paths that they take are a little bit differently because we have this road that's built up here. So I'm going to go across the other side and just see if it's any different. This channel kind of banks around that way, and this one comes around this side. All right, so our salinity here is 32.3, pH 7.96, dissolved oxygen 7.3, temperature 13.3 Celsius. All right, let's go up to the headwaters and see what we got. Nice. We're at the headwaters, well, not really headwaters of this stream, but where this creek is entering this reserve here. So as high as we can get in this marsh, in the freshwater system, before the marsh gets interrupted by a railroad and a highway and coastal development. So I'm going to stick the probe here in this spot. You might be able to see the culvert where the creek has been allowed to flow underneath the railroad into the marsh. So here, as we're at the end of the highest high tide, 6-foot high tide, a really good one. We have a salinity of 32.3 PSU, pH 7.97, dissolved oxygen 7.5 on the nose, and temperature 13.3 degrees Celsius. So this road that's been built through this marsh before it was a protected area, the creek flows in on the right side of the road. And so in this side, it's a little less open to the creek. Let's see how the salinity looks here. Such an amazing high tide. Oh, I see a crab crawling. A little Pachygrapsis right there, a line shore crab. Sweet. just taking a minute, and now we have our salinity 32.31 PSU, pH 7.94, dissolved oxygen 7.45, temperature 13.45 C. Interestingly, a little bit warmer over here. The water is more shallow. It's not flowing as well. Nice. Okay. Nice. Great.